Hi everybody, this is Yavaş from BigInfinity.net. Welcome to my topology class. In my first video, I've tried to prove a proposition about homotopy extension property. And in this section, I'm going to complete my proof. So, if you haven't seen my first video yet, I put a link here. Yes, so you can watch it out. Okay, let's complete our proof. There is actually nothing much left to prove, but we need to do something to complete it officially. Okay, as I already proved, we have our fantastic deformation retraction, and actually we are gonna use it, okay, to rest of process to prove our general theorem. Okay, we have a deformation retraction for any arbitrary n-dimensional disk. And as I already showed you, this deformation do something like this. Okay, let's put a step forward and prove our theorem for a little more complex space. Okay, actually there is nothing complex here, but I should say that. Okay, imagine our space made by its subcomplex with just a disk, like you see in the picture. As you know, if we have a CW pair, okay, X and A, we can actually create our original cell complex with attaching different disks to its subcomplex like A. For example, I just attach one-dimensional disk. In here I attach it n-dimensional, but it's like two-dimensional, you know, because I can't draw a n-dimensional. Okay, let me attach a one-dimensional disk to A2. Okay, for this case, our deformation retraction is work 2, so there is nothing else need to do to find, for example, a deformation retraction to retract this, to retract, for example, this space. Sorry. Yes, that's true. Okay, to retract this space to this space. Okay, A in I. Okay, we just need to use our original deformation retraction. We can actually expand it, okay, so it can work for this space too. Okay, like this. Our new deformation retraction is identity on A, and it is our original deformation retraction on our disk. Okay, so there is nothing to prove for this case. Okay, so if we have, for example, one disk attached to A, or a space made like this, okay, we can extend or deformation retraction, extend deformation retraction on our disk to the or whole space. Okay, and there is nothing gonna be different if we have, for example, another disk here too. Okay, but there is a tricky situation here. Okay, if we have two disks with different dimension attached to our subcomplex, okay, we can do every one of them. Okay, as you know, when we want to build a cell complex, we start with an, for example, empty set, and after discrete set, and after that we glue one-dimensional disk to our space. After that we glue two-dimensional disk to our space, and so on. So we need to retract every n-dimensional disk together. For example, if we have a one-dimensional disk here and a one-dimensional disk here, actually we can retract both of them together. Okay, so for this case, let me explain this, and I want to talk about something with you. So imagine our original space is made by an A with two one-dimensional disk. Okay, for example, another disk, I call it D1 and D2. Okay, every one of them has its own deformation retraction map. Okay, for example, call it R1 and R2. Okay, in this case, as before, we can extend both of them to a function like this. Okay, let's call it, show it with a big R, for example, something like this. Okay, and our function is like this. Okay, it is identity on I, A, and when we restrict it to our disk, we get something like this. For example, R1T and R2T. Okay, let me see. Okay, something like this. But if we have, for example, something like this, okay, imagine this is a two-dimensional and one-dimensional. We attach a two-dimensional and one-dimensional disk. Okay, we should retract them after each other. We shouldn't retract them together because maybe some of them glue to another one. So we should retract them by one by one. Sorry, we should retract them one by one. So if we have, on this case, okay, we should, so for example, we have our A, keep it on your mind. Okay, let's go to a, for example, more general case, or X, for example, made by a subcomplex, okay, this is our subcomplex, for example, some one-dimensional disk and this is the most general case we could have. Okay, we have our A and we attached different disk with different dimension to it. Okay, in this case, okay, we have a deformation retraction for any dimension. For example, we have a deformation retraction for one-dimensional disk, deformation retraction for two-dimensional disk, and so on. So in this case, what should we do? Okay, we should rescale or time interval, and in each step retract one of dimension. Okay, and this is how we can reach our actual deformation retraction for our whole space. Okay, so it's not very hard. We just need to retract any of them in this interval. Okay, and we are going to have our general deformation retraction. Okay, for example, we use this retraction, we use this retraction, we use this retraction. Okay, in this interval we use this retraction, in this interval, and so on, and that's it. And eventually we retract all of n-dimensional disk. Okay, and our A or subcomplex stay stationary. Okay, so with this strategy we actually retract our original space to this. And this is how our proof is completed. Okay, I design a 3D model for you to give you some intuition about this case especially, okay, and how it works, and I hope it helps you to get better understanding. Okay, for example, it in this very special case, okay, we have our D1 here, for example, and as you see, we can retract it to, for example, normal D1. Okay, so our retraction is going to be something like this. A stay stationary in our case, and we retract the attached disk. Okay, so we retract our disk like this. Okay, but this is not the actual motion. As I told you, I just want to give you some intuition what's going to happen when we attach a disk to our subcomplex. Okay, we use the deformation retraction to retract just this part of our space. Okay, so as I told you, there is nothing going to do, nothing going to do with this part. Okay, let me check something. Okay, so let me check, is there anything I should told but I forget? So I don't think so, and that's it. We complete our proof, so we should retract our disk in different interval and it will complete our proof. Okay, that's it. I hope you enjoy my video. Don't forget like my video and subscribe my channel, and thanks for watching and see you later.